Now we are seeing the topic that is differential equation. The subtopic is method of variation of parameter. So this is the one more method to find out the particular integral, and this method was evolved by the Lagranges. Okay. Now why it is called as the variation of parameter, we'll see. We have considered here the second order equation, that is a d square y by dx square plus a1 dy by dx plus a2y equals to x, where this a1 and a2 are the constants. Okay, and this x will be a function of x only or maybe a constants, that depends. Now after that we know very well how to get the CF, that is complementary function for this second order equation. Okay, and that CF we are denoting by this is the actually complementary function. This we are having a complementary function, that is CF, and that CF we write down as C1 y1 plus C2 y2. For example, if I am having the root as it is what 2 and minus 3, what is CF? C1 e raised to the power 2x, roots are real and different, plus C2 e raised to the power minus 3x. So to this quantity I can equate it with C1 y1 plus C2 y2. So y1 is e raised to the power 2x, y2 is e raised to the power minus 3x. Is it okay? So this way we write down the complementary function for this second order equation, that is C1 y1 plus C2 y2, where this y1 and y2 are functions of x. Now with the help of this CF we write down the PI by using the variation of parameter. So what we variate here, actually we variate the C1 by u and C2 by v. So हम इसको variate कर रहे हैं, therefore it is called as the variation of parameters, and the PI will be given by then it is u into y1 plus v into y2. तो हमने चेंज क्या किया है, arbitrary constants को, C1 C2 are replaced by what is it, u and v. Okay, so this is the PI, and combination of the PI and the CF results the complete solution for this. Our job is now, our task is to find out this u and the v. y1 and y2 is already known to you, जैसे हमने देखा this y1 and y2 are already known to you. हमें सिर्फ निकालना है, it is what, u and v. तो u का formula है, that formula you have to just remember. Okay, it is already derived. It is the integration of minus y2x upon Wronskian of y1 y2 dx. So this y2 we can obtain from the CF. Okay, and then x is nothing but what, RHS part of the equation, and Wronskian we calculate. What is the Wronskian actually? Wronskian of y1 y2 is nothing but the determinant. What is that? In the first row we write down y1 y2, and in the second row we write down the derivative of this y1 and y2, that is y1 dash and y2 dash. This is y1 dash, it is y2 dash. Now solving this determinant means doing the cross multiplication, that is y1 y2 dash minus y2 y1 dash, that gives the Wronskian. और ये Wronskian आपको डिनोमिनेटर में लिखना है of u, and evaluating this integral you will get the u. Similarly we are having the formula for the v. It is v equals to y1 x upon Wronskian of y1 y2 dx. y1 from CF, then x is the RHS part of the equation, and then this Wronskian already calculated, put it here and evaluate this integral, and putting these values of u and v in the PI. PI is what, u into y1 plus v into y2, and complete solution is the y equals to CF plus PI. Okay, that results the complete solution, y equals to CF plus PI. So this is the way to solve the example on variation of parameter. So first job is to find out the CF, that is C1 y1 plus C2 y2. Then we write down the, by using the variation of parameter PI as PI equals to replacing the C1 by u, C2 by v. So PI will be, it is what, u into y1 plus v into y2, and we are having a standard formula for the u and v. Calculate that. Okay. So the differential equation is given to you of second order. It is a d square plus 1 into y equals to cot x. Okay, this can be solved by the general method as well as to find out the PI. Okay, now this variation of parameter we use to find out the PI actually. Okay, this is another method to get the PI, because whenever a problem is not fitted into the particular cases, that is of exponential, sine, cos, or maybe a polynomial, so that time we go for that is general case, or for it is variation of parameter. So our first job is in variation of parameters to find out it is complementary function. Equation is given to you. We write down the auxiliary equation for that. Okay, that will be the m square plus 1 equals to 0. We find out the roots. This minus 1 taken there to the RHS part, minus 1 square root plus minus I. Minus 1 ka square root plus minus I stand for the root of minus 1. Okay, we are having the two roots plus I and minus I, but the roots are imaginary. So we have to equate this with the alpha plus minus I beta. So alpha will be the 0 and beta is 1. Okay, so writing the CF, then it is e raised to the power 0x, that is alpha is 0. So e to the power 0 is 1, leaving that term. Then C1 cos beta x, beta is 1, plus C2 sin beta x, beta is 1. Okay, equating this CF with C1 y1 plus C2 y2, so that we get the y1 as cos x, y2 as sin x. Okay, this we have written here. Now next job is to find out the Wronskian value, Wronskian of this y1, y2, and that is defined by the determinant y1, y1 dash, y2 and y2 dash. y1 is written, y2 is written. Take a derivative of y1, cos ka derivative minus sin, or sin ka derivative is what? Cos. Solve the determinant this by cross multiplication here, cos square x minus of minus plus sin square x, and we know that very well, cos square x plus sin square x is 1. Okay, so the Wronskian value we got as 1. The Wronskian may be a function of x or may be a constants. Okay, that depends. और यहाँ पे हमें constant मिला हुआ है. Then by method of variation of parameter, we write down the pi. That is, we variate here the constants C1 and C2 by it is u and v. Therefore, it is called as the method of variation of parameter. Then u into y1 plus v into y2. So y1 y2 आपको known है, हमें निकालना है u और v. So the u is having the formula minus integration of y2x upon Wronskian into dx. So y2 is what? Already listed there. It is a sin x, and then x is what? RHS part, that is cot x, and Wronskian is 1. Cot we know that very well, cos by sin, sin get cancelled. Integration of cos is left, and integration of cos is sin x. Okay, and the minus is already there, u equals to minus of sin x. Next we find out it is v by the formula integration of y1x upon that Wronskian into dx. So y1 is what? Cos x, already listed. X is the cot x, RHS part of the equation. Wronskian we have calculated, w we denote for the Wronskian. Okay, in short it is 1. Then cot is what? Cos by sin, cos into cos, that is cos square x. We have to do the integration of cos square x by the sin x, and we have the relation, that is 1, sin square x plus cos square x equals to 1. So therefore cos square x can be written as 1 minus sin square x. Now dividing this, 1 by sin x, and this is a sin square x by sin x. Okay, now further 1 by sin x and this sin square x by sin x, one sin get cancelled, we are left with only sin. 1 by sin is what? Cosec. Now it is very simple doing the integration of this trigonometric functions. So we are having standard formulae, integration of cosec, minus बाहर था कि यहाँ पे नहीं, ठीक है, this is not. Integration of cosec, what is it? Log of cosec x minus cot x, standard formula. Then integration of sin, it is what? Minus cos, this minus minus get plus, so this is the required v, and pi is given by the u into y1 plus v into y2. So we are having all four known things. u we know, already calculated, y1 we know, v आपको पता है, y2 आपको पता है. So putting all this value, simplifying the quantity. Okay, open the brackets, this first term and the last term get cancelled. We are left with the sin x into log of cosec x minus cot x. That is our required pi. Then we write down the complete solution as CF plus pi. Y equals to CF plus pi. Writing the CF, writing the pi. Okay. So this way we solve the example on method of variation of parameter. Our first job is to find out the complementary function, and to that complementary function I equate that to the C1 y1 plus C2 y2. And by method of variation of parameter, we write down the pi as variating the C1 and C2 by u and v. So pi will be u into y1 plus v into y2. So u and v is having the standard formula. Use that to get the u and v, and then combining all that u and y1 plus v into y2 to get the required pi. Clear? So this way we find out the pi by the method of variation of parameter. So this is the one more method to get the pi. Okay. So it is a generalized method. We can use the general method or maybe the method of variation of parameter to get the pi. Thank you.